Hi everyone, this is lesson 4.3, and in this lesson I'm going to talk about some special types of annuities, deferred annuities and perpetuities. So we've covered the four major types of annuities. Remember, we had ordinary annuities, payments at the end of the period, and annuity due, which was payments at the beginning of the period. And then for each of them, we had two different options. We had simple versions, okay? So remember that interest compounding frequency and the payment period frequency were the same. Or general annuities, where the interest compounding period and payment period frequency were not the same, okay? So a deferred annuity can encompass any of these types of annuities. But basically, the main difference is that your first payment, or when you start receiving payments, if you're receiving them in the annuity, they happen at a later date. So let's say a good example of this is if you go to a furniture store and they've got no payments for 2 years, okay? So you buy your furniture, but you don't have to pay for 2 years. That's deferring your payment schedule by a period of 2 years. So that's an example of a deferred annuity, okay? So a lot of times in that example, for furniture, let's say no interest, no payments, but sometimes they do, depending on where you buy it from, have interest for that period in time. So to do a deferred annuity, there's basically an extra step you have to do, right? So you have to, if you remember back to our first unit, we talked about something called the focal date, okay? So that's the date that we're actually referring to, whether it's today, which we usually call time zero, or some period in the future, okay? So if we look at this example that I have here, so what if you had a loan of $10,000, okay? You had it today, but you can defer your payments for the first 6 months, even though you're still accruing, or you're still have interest calculated on it. It's just maybe you don't have the money right now, so instead you're not paying for 6 months. So how do you calculate the value of those payments, assuming they start 6 months from now? Well, again, if you remember, I like doing these graphs, okay? So we'll call today, in all of our examples today, time zero, okay? So we have a loan, all right? And let's say this loan, you have to pay it off for 5 years. Okay, I'm just throwing that number out there. Normally I'll give you that number, but you're not paying for the first 6 months. So really, your loan doesn't start until here. So we'll call this time 0.5, okay? And then for that period in time, I called it 0.5 because it's half a year, 6 months, okay? Now, from that period in time on, you have 5 years to pay your loan back. So the end of your loan, we'll call it 5.5, because it would be 5.5 years from your starting point today, all right? So 6 months for when you have payments, which is half a year, plus, in my example, I'm saying 5 additional years to pay it off, okay? So what you have to do is you know that your value of your loan is $10,000 today, right? But your payments, okay, what you're trying to find, don't start until this period here, okay, until 6 months from now. So you're going to earn interest on that $10,000 that you have to pay back. So your loan will actually be a little bit more than $10,000. So to do that, you actually have to calculate the future value of that $10,000 at that period 6 months from now when your loan is starting, right? Because that is your focal date for your annuity. That's when your annuity is actually starting. So remember, from our first unit, the two formulas we had, future value was present value times 1 plus your periodic interest rate to the exponent n. Or in some examples, you might have to work backwards, okay? So remember, to work backwards, you had your present value was simply your future value divided by 1 plus your periodic interest rate to the exponent n. Okay, so that's your first step you have to do to translate the amount of money, this $10,000, to that appropriate focal date. Okay, then, once you're there, all the same steps apply. If it's an ordinary simple annuity or a general annuity, those same formulas And if you remember, formulas like future value is your payment times 1 plus your periodic interest rate to the exponent n minus 1 divided by I. Okay, those formulas now all apply. So your trick after that is figuring out which type of annuity it is. All right. So what I'm going to do is I'm going to do 2 examples where I show you, okay, examples of a deferred annuity. And I'm going to explain how I know what type of annuity it is, right? Because that is going to determine, which form that you use, future value or present value, okay, first. Then it's going to determine which formula that you use for the annuity, whether it's a general annuity, a simple annuity, an annuity due, or an ordinary type of annuity. Okay, all the different types we've been talking about throughout this course. Okay, so let's look at our first example. What is the size of the payment required at the end of every 3 months to repay a 5-year loan of $25,000 if payments are deferred for 2 years and interest is 6% per annum compounded quarterly? Okay, so my first step, and like I said, you've seen me in the other lessons, or heard me, I guess, since we're not actually in person. You've heard me describe my process as to how I determine what type of annuity it is. So that is important as your first step in looking at these questions. All right, so I'm going to kind of introduce to you a 3-question method after we do a couple of examples. But for this first example, I'm going to start by saying, okay, it noted, first of all, it was deferred for 2 years. Okay, so it's a deferred annuity. And then the second item that I notice, okay, is payments are at the end of every period. That makes it an ordinary annuity. And the last thing you look for is whether the interest compounding frequency and payment compounding frequency are the same or not. In this instance, every 3 months means quarterly for payments, and interest is also quarterly. So that means that it's an ordinary, simple annuity. Okay? And in this instance, it's deferred. So I did that, okay, and it's basically a fill in the blanks process. As you ask yourself each of these questions, you can fill in a little piece of this. As you can see, I filled in deferred, then I filled in ordinary, and then I figured out that it was a simple annuity, okay, not a general annuity. All right? So those are my first steps. So I know it's an ordinary simple annuity, and I know it's deferred. So if it's deferred, I'm going to start with a timeline. Okay? So what it's saying is that today is time 0. Your payments are deferred for 2 years. So your start of your annuity doesn't happen until year 2. Okay, so that's year 2 on my timeline. And then your loan is 5 years from that period. So you add 5 years, 2 plus 5 means you're done paying this off in 7 years. Right? So you start paying 2 years from now, then you pay for a 5-year period, which brings you to year number 7. So what it's asking you for in this question is payment. Okay? And what you're provided with is that your loan is $25,000. So you know today your present value is $25,000. Okay? And your annuity starts right here. Okay? A time of 2 years. Okay? So your first step is you need to figure out what the value of that loan is at the start of your annuity. So what is the future value at this point? And then you can take all that information and you can determine your payments using the same formula for an ordinary simple annuity. Okay? So it's one additional set of steps you're going to see here that I do in order to solve these problems. So we start off and we have to find the future value here. And remember, the future value for this is just plain compound interest. We don't have payments. Okay, we don't have anything. It's just future value. So future value is present value times 1 plus your periodic interest rate to the exponent n. Okay, and n in this case is the number of interest compounding periods, right? Because there's no payments in these. It's just simple, it's just compound interest. So to solve that, what variables do we know? We know our present value of our loan is $25,000. Our nominal interest rate, J, is 6%, which is 6 divided by 100, removing the percentage sign, which is 0.06. Your number of interest compounding periods is quarterly, so M is 4. So your periodic interest rate, I, is J divided by M, which is 0.06 divided by 4, or 0.015. And lastly, for this instance, your N in this case is your number of interest compounding periods. Okay, so you're translating this present value to this point here 2 years from now. So that means you have 2 years multiplied by 4 compounding periods per year, because it's quarterly, so N is 8. Okay? So if you substitute those into your formula, your future value is equal to 25,000 times 1 plus your periodic interest rate, 0.015, to the exponent 8. So your future value is equal to $28,162.31. Okay? So you can write that number right here. We can erase this future value. And we know that the future value number is $28,162.31. So that is actually your present value at time of 2 years, right? So looking at your next step, all right, most of your variables have already actually been solved here. So I'm going to move to another slide and kind of translate this information so we can finish doing this question. Okay, so we started out, I'll draw our graph again. This is time 0. This is 2 years from now, and when our loan payments are done is at year 7. So we started off, remember, we had 25,000 as our present value of the loan today, and our future value was calculated for year 2 of $28,162.31. Okay. A couple other variables that we calculated. The major one to keep in mind is we calculated the periodic interest rate, and it was 0.015. Okay. The other thing to note was that this was an ordinary simple annuity. Okay. So what we're trying to find now simply is the payment. So the payment for an ordinary simple annuity is equal to the present value times your periodic interest rate divided by 1 minus 1 divided by 1 plus your periodic interest rate to the exponent n. Okay? So the variables we know, okay, we already know the periodic interest rate I because we calculated it in the first part. We know our present value now because we've calculated it at our current period in time, which now we're at 2 years in the future. So our present value is $28,162.31. So the last item that we need is simply N. So in this case, N is our total number of payment periods, right? Because this is for an annuity. So we're paying it off over 5 years, and we're paying quarterly, the end of every 3 months. So 5 times 4 gives you a total number of payments of 20. So given this, we can simply substitute now all of these variables in. So that equals our present value, $28,162.31, times our periodic interest rate, 0.015, divided by 1 minus 1 divided by 1 plus the periodic interest rate, 0.015, to the exponent 20. So again, doing this in steps, our payment would be equal to $422.43, that's in the numerator, divided by 0.2575 if you calculated both them out, and you obtain a payment value of $1,640.50. Okay? So as you can see, there was one additional step using the formulas from your first unit on compound interest. Okay? So again, for this test, what I'm going to give you is I'm going to consolidate the formulas for each type of annuity as well as compound interest. Okay? And I'm going to actually label them by type. Okay? My intent for these questions is I want to see you determine the right type of annuity. Okay? And then use the formulas appropriately. Okay? So I'm not expecting you to have memorized that this formula is for a general annuity and this formula is for a simple annuity. Okay? So let's look at a second example, okay, before I give you some steps. What payment can be withdrawn at the beginning of each year for 6 years if $5,000 is invested today at 12% compounded monthly and the payments are deferred for 10 years? Okay, so again, what I start with is I pick out the relevant information to determine what I'm dealing with in this question. So first step, is it a deferred annuity? Well, it notes that it's deferred for 10 years, so that's yes. So I start, it's deferred. That means I'll have to do a timeline. Then I look and I say, is it an ordinary annuity or an annuity due? All right, so payments are the beginning of each year, not the end. That makes it an annuity due. Okay, that's from lesson 4.2. Then your last question is, are your interest compounding frequency and payment period frequency the same? Okay, so in this case, payments are withdrawn each year, so yearly, and your interest is compounded monthly, so they are not the same. That makes this a general annuity due, as opposed to a simple annuity due. Okay, so every time you look at a question, you follow these steps. All right, so now I know it's a general annuity due and I know it's deferred. So my first step is I have to start with a timeline. Okay, so today's time 0, and it notes that your payments are deferred for 10 years. So that means time 10. And the payments are happening for a period of 6 years. So that means from 10 years from now onward for 6 years, that puts you at time 16 years from now. That's when your payments will be completed. Okay? So we start with, we've got our timeline. Okay? We know kind of where our focal date needs to be, or where we need to get to. Okay? To 10 years. So what information do we have? We're investing $5,000 today. So that means our present value of the money we have is $5,000. And as our first step, we know that we need to get that, we need to translate that money to this period of 10 years. We need to find the future value 10 years from now. So we start with that, all right? Our future value is equal to our present value times 1 plus the periodic interest rate to the exponent n. So our present value in this case is $5,000. Our periodic interest rate is calculated the same. So first, our nominal interest rate, J, is 12%, which is 12 divided by 100, which gives you 0.12. Thought I did that wrong. M, in this case, okay, interest is compounded monthly, so M is 12. So your periodic interest rate, I, is J divided by M, which is 0.12 divided by 12, or 0.01. Okay, and our last step here is N. So in this case, N, we have 10 years, all right, and our interest is compounded monthly, so 10 years multiplied by 12 gives us 120 interest compounding periods. Okay? So if we substitute all these values in, our future value is equal to 5,000 times 1 plus 0.01, our periodic interest rate, to the exponent 120. And our future value becomes $16,501.93. Okay? So that, okay, is the value here. So that becomes our future value at 10 years from now. Okay? So now, once we've done this compound interest calculation, now we're looking at an annuity. Okay? And remember, this is a general annuity due. All right? So again, I'm going to provide you the formulas for each type: an ordinary simple annuity, an ordinary general annuity, a simple annuity due, and a general annuity due. Okay? I'm not expecting you to have to differentiate those formulas. What I want you to do is I want you to figure this piece out first, and then use the appropriate formula from that. Okay? So in this case, it's a general annuity due, and we're trying to find the payments. So if you look at your formula sheet for that, you have your payments is equal to your present value times the equivalent interest rate, P. Remember, this is a general annuity, not a simple annuity, divided by 1 minus 1 divided by 1 plus the equivalent interest rate, P, to the exponent n. And this is multiplied by that additional interest term, 1 plus the equivalent interest rate, because it's an annuity due. All right? So some of the items that you know here, you know your present value, okay? Because that's equal to the number you calculated, $16,501.93. You also know your periodic interest rate from your previous calculation of 0.01, right? Because in all these examples, the interest rate doesn't change from the period that it was deferred for to the period that it's an annuity. Okay? So the next item that you need, right, is you need your ratio, because this is a general annuity. That's your number of interest payment or compounding periods divided by your number of payment periods, both per year. And in this case, your interest is compounded monthly, and your payments are yearly. So it's 12 divided by 1, which gives you 12. So with that, you can calculate your equivalent rate of interest, P. Remember, it's 1 plus the periodic interest rate to the exponent C minus 1. So P in this case is 1 plus 0.01 to the exponent 12 minus 1. So your value for P here is 0.1268. Okay? Your last step is you need N. And in this case, because it's an annuity, N is a total number of payment periods. So N, in this case, you're getting paid for 6 years, and you're getting a payment at the beginning of each year. So 6 times 1 gives you a value of 6. So just like we've done in our other pieces of this unit, in our last unit, you just substitute all of these values in. Okay? I'm going to put a line here just so you can see the difference. So your payment, in this case, is equal to your present value, $16,501.93, times your equivalent interest rate, 0.1268, divided by 1 minus 1 divided by 1 plus the equivalent rate of interest, 0.1268, to the exponent 6, multiplied by that additional interest term, 1 plus 0.1268. And again, that's because it's an annuity due. So if we do this in steps, okay, our payment becomes, in the numerator, $2,092.44, divided by this first area in brackets, okay, sorry, that should be a different color. This first area in brackets, okay, which is 0.5114, multiplied by the second term, which is 1.1268. So if you calculate this out, you get a payment of $3,631.16. Okay, so there isn't much difference in this except that you're basically combining these two pieces together, doing the compound interest piece and doing the annuity piece kind of in one set of steps. Okay, so hopefully you saw from the last two examples that there were different types of annuities. So they needed different formulas based on what type of annuity it was. So I want to do just a slide that shows you which formula to use and how to determine it in the easiest way. So the way that I always look at it, and you've seen me, or I guess heard me do it in lessons, okay, is to kind of fill in the blanks. All right, so the easiest way is you start, I like to start with 4 blanks. Okay, and those blanks are not very, very straight, but that's okay. As I answer these questions, I'll fill in those blanks. All right, so the first question is, are the payments deferred? Okay, so you saw in the first or in the second example they were deferred. If it's a yes, okay, then at the very last blank, in brackets, I write deferred. Going to the second question, now I'm looking at, are payments at the beginning or the end of the period? Okay, so let's say I said beginning, okay, then I could fill in the next blanks. It's an annuity due. Last question is, are the interest period or interest compounding and payment period frequency the same? So if I answer yes, okay, then it's a simple annuity due. Okay, if I change that answer, right, and they're not the same, remember back to unit 3, it's a general annuity due, and the general ones have the equivalent rate of interest P, so that extra set of steps to calculate it. So if I go all the way back, okay, it's still a deferred annuity, but let's say it's the end. Okay, payments are at the end of the period. That was the unit 2 that we did. That means it's an ordinary annuity. So ordinary in the first blank, annuity in the third one. Your third question is then, are the interest and compounding periods the same? If it's yes, then it's an ordinary simple annuity that's been deferred. If the answer is no, then that means they're not the same. So it's an ordinary general annuity that's been deferred. Going back, if the annuity was not deferred, then in this case, it's just an ordinary general annuity, which we covered in unit 3. Okay, so all of these examples just show you that filling in those blanks helps you to determine kind of which type of formula to start using. Again, like I said, I will give you a formula sheet that has the formulas listed for each type of annuity. Okay, so the work that I want to see you do in a question is to make sure you get the right type of annuity. Okay, that's going to contribute to a lot of your marks on this Unit 4 test. Okay, and filling in those blanks makes it easier because I want you to fill in those blanks correctly, go to your formula sheet, and then pick the formula based on that set of information that you answered. Okay, so I'm not encouraging you to know every single formula to all of them. All right, so now I'm going to look at 3 more examples. Again, I'm going to follow these same 3 steps in each one of those questions just to help you kind of see those differences. So the first question, payments of $500 are due at the end of each year for 10 years. If the annuity is deferred for 4 years and interest is 6% per annum compounded annually, determine the present value of the deferred annuity. Okay, so again, you start with your questions. The first question, is it a deferred annuity? Well, it says payments were deferred for 4 years. I also noted it was a deferred annuity here in the question. So again, starting with your 4 blanks, your last blank, it's deferred. Okay. Next question is our payment at the beginning or the end of the period. In this question, it's the end of the period, so that makes it an ordinary annuity. Okay. Third question, are the interest, compounding frequency, and payment period the same or not? Payments are due at the end of each year, and interest is also compounded annually. So yes, they are the same. That makes this an ordinary, simple annuity that's been deferred. All right? So once you've figured that out, you can go to your list of formulas for an ordinary, simple annuity. Okay? Once we determine what we're going to calculate. But since this is deferred, we're going to start with our timeline. Okay? This is time 0. Our annuity is deferred for 4 years. So we're going to 4 years. And then the payments are due for a period of 10 years. So from year 4 onward, you're paying for 10 years. So that means 4 plus 10 means you're finished at year 14. Now, the items that we know in here, okay, what are we looking for? We're looking for the present value, okay? So that would mean the present value today. But in order to solve that, we have to solve the annuity first, okay, and solve for the present value at year 4, right? So we're going to solve for the present value in the annuity, which will give us the present value here, right? So let's start with that step first, okay? Because at the end, we want to take that value and translate it back to today to find the present value in today's dollars, okay? So it's an ordinary simple annuity, and we're trying to find the present value. So the formula for that, present value, is equal to the payment times 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n divided by the periodic interest rate. Okay, so the items we know our payments are $500. Our nominal interest rate is 6%, which is 6 divided by 100, removing the percentage sign, which is 0.06. M, our number of interest compounding periods, is compounded annually, so it's 1. So our periodic interest rate, I, is J divided by M, which is 0.06 divided by 1, or just 0.06. Okay? The last item we need in this is N, our total number of payment periods. So in this instance, we're paying for 10 years, and we're paying at the end of each year. So 10 times 1 payment per year gives us a value of 10. Substituting all these values into our formula, I'll actually move it over so we have a little more space. Our present value is equal to 500 multiplied by 1 minus 1 divided by 1 plus our periodic interest rate, so 1 plus 0.06 to the exponent 10, divided by our periodic interest rate, 0.06. So our present value is equal to 500 times this bracket, okay, which if you calculated it correctly, comes out to 7.36. So our present value is 3,680. But remember, that's our present value at the start of the annuity, which is 4 years from today. So we can substitute that value in here, okay? So we go, going back to our timeline, that our present value there is 3,680. But we want to know the present value today, right? So that means in 4 years' time, our investment is worth 3,680. So that becomes the future value for our next calculation. So now if we want to find the present value, simply this isn't an annuity, we have the future value. It's just the compound interest formula. Okay, so present value is equal to future value divided by 1 plus your periodic interest rate to the exponent n. N, in the case of compound interest, is the total number of interest compounding periods. So our future value, we know at year 4, our annuity is worth $3,680. We know from our previous calculations the periodic interest rate, I, is 0.06 because it doesn't change. And the only item we don't know is n, our number of interest compounding periods for these 4 years. But we do know it's 4 years and interest is compounded annually. So 4 times 1 gives you a value of 4. So now we simply can substitute that value in. So present value is equal to 3,680 divided by 1 plus the periodic interest rate, 0.06, to the exponent 4. So our present value becomes $2,914.90. So what we've done is we've basically done this question backwards to how we did the future value question. So remember when we started and we wanted to know kind of the future value, we started with knowing the present value and we worked towards the future. In this instance, we're starting from our annuity in the future and we're working backwards. Okay? Watching all these different types of examples will kind of show you the process for each type. Okay? Okay, so let's look at another example. A lease contract that has a present value of $64,000 requires payments at the beginning of each month for 7 years. If the payments are deferred for 2 years and interest is 8% per annum compounded quarterly, what is the size of the monthly payment? Okay, again, I'm going to start the same way. There are 4 blanks. First question, is it deferred? Okay, so it says that payments are deferred for 2 years, so that means it's deferred. The second question, are payments at the beginning or the end of each payment period? In this case, it's the beginning. So that makes it an annuity due. And lastly, are the interest, compounding frequency, and payment period the same? Okay, so payment periods are the beginning of each month, so monthly, and interest is quarterly. So they are not the same. That makes it a general annuity due. Okay? And since it's deferred, we have to start again with a timeline. Okay? So today's time 0. Payments are deferred for 2 years. So the start of your annuity is until 2 years from today. And payments are made for 7 years. So that means they're made for starting at year 2 for 7 years. So 2 plus 7 means by year 9, you will have paid off this lease. Okay? Good example of one of these leases would be if you bought a vehicle like a truck, okay, where you lease the truck for 7 years. So now we have our timeline. What information do we know? We know our present value today. How much the lease was worth today is $64,000. But our lease payments don't start for 2 years while it still accrues interest. So we need to find the future value at year 2. Okay, so we can use that as our base for our annuity calculations. So let's start with that, our future value is equal to our present value times 1 plus the periodic interest rate to the exponent n. So the information we know our nominal interest rate is 8%, which is 8 divided by 100, removing the percentage sign, or 0.08. M, in this case, for interest is compounded quarterly, so M is 4. So your periodic interest rate, I, is J divided by M, or 0.08 divided by 4, which is 0.02. Lastly, for this, our number of interest compounding periods for this compounding interest calculation, N, Well, payments are deferred for 2 years, and interest is compounded quarterly. So 2 times 4 compounding periods per year gives us a value of 8. So our future value is equal to our present value, which is 64,000, multiplied by 1 plus our periodic interest rate, 0.02, to the exponent 8. Okay, so if you calculate that out, it means our future value is $74,986.20. So that's how much this lease is worth 2 years from now, because you deferred payments and still accrued interest on it. Now we have the value at the start of your annuity, or the present value at year 2, right? This $74,986.20. So now what we're trying to find is the size of your monthly payment. Okay, so we know it's a general annuity due, and we're trying to find the payment. Okay, so on our second piece, we can start with our payment. Okay, it's a general annuity, and I put in brackets normally due for an annuity due. So that's equal to our present value, because we know the present value at this time, the $74,986.20, multiplied by the equivalent interest rate P. Remember, it's a general annuity, so we have to use the formula with the equivalent interest rates. Divided by 1 minus 1 divided by 1 plus the equivalent interest rate P to the exponent n. And that's multiplied by this additional interest term 1 plus P. Remember, because it's an annuity due. Okay, so all of those puzzle pieces determine the formula to use. All right. Now, what information do we know? We know our present value, $74,986.20. We know our nominal interest rate because we already calculated it. It's 0.02. We need to calculate, though, our equivalent rate of interest. So we need our ratio, C, which is the number of interest, compounding periods per year, versus the number of payment, divided by, So interest was compounded quarterly, and payments were monthly. So that means 4 divided by 12. And that gives us 0.3 as a repeating decimal, 0.333, extending forever. So next, calculating our equivalent rate of interest, P, is 1 plus the periodic interest rate, I, to the exponent C minus 1. So P is equal to 1 plus 0.02 to the exponent 0.3, and that's 0.3333. You can put only a couple threes in if you want, like 0.333 into your calculator, and that's just fine. And then all of that is minus 1. So if you calculate that out, you get an interest rate of 0.00662. So the last item that you need here, okay, is N, total number of payment periods. So we're paying for 7 years and we're paying monthly. So 7 times 12 is 84. So now we can substitute all of these values into this formula. So our payment is equal to $74,986.20 times 0.00662, the equivalent rate of interest, divided by 1 minus 1 divided by 1 plus the equivalent rate of interest, 0.00662, to the exponent 84, multiplied by 1 plus 0.00662. Okay. If you're running out of space on these questions, I gave you an extra slide on your notes that you can then continue to write on. So if you calculate this out again in steps, your payment is equal to, in your numerator, you should get $496.41, divided by the first bracket, 0.4255, multiplied by that additional interest term, 1.00662. Okay? And if you calculate this out, you'll get $1,158.98. Okay? So that is your final payment. So our last example for these deferred annuities. So payments of $1,000 are due at the end of each year for 5 years. The payments are deferred for 3 years and interest is 10% per annum compounded quarterly. What is the present value of the deferred payment? Okay, again, I'm going to start with my 4 blanks. I noted that it was deferred. Okay, so in this question, you're looking for that. So it's deferred. That's question number 1. Question number 2 is are payments at the beginning or the end? In this case, it's at the end. So that makes it an ordinary annuity. Question number 3 is interest, compounding frequency, and payment period the same? Well, payment periods, okay, they're due yearly, and interest is compounded quarterly. So again, they're not the same. So this is an ordinary general annuity. Remember, back to Unit 3, and it's deferred. All right? So I'm going to start just like I did in the last question with the timeline. We're at time 0. Payments are deferred for 3 years. So the start of this annuity is 3 years from today. And your payments are due for 5 years. So 3 plus 5 means this will be due after 8 years. Okay? The information that you know, all right, is you know your payments. And what you're looking for is you're looking for the present value of the deferred payment. So you're trying to find this value. Okay, so this goes back to our 3rd example in this lesson. Okay, so what we need to find is the present value of this annuity, which would be at year 3, right, when the payments start, and then discount that back to obtain a present value today at time 0. All right, so we start with our annuity, and then we do the compound interest formula. Okay, so we know we're looking for our payments, and we know it's an ordinary general annuity. So we go back to our formulas from that unit, Unit 3. So our payments for an ordinary general annuity are equal to sorry, that's the wrong equation. See, it's easy to kind of look for the wrong equation. In this instance, we're asking for the present value. I had it in my head that it was payments. So everybody makes those types of mistakes, and that's why I don't edit them out in these videos. So we're asking for the present value, which means we need to use the present value formula for an ordinary general annuity. So the present value formula is equal to your payments times 1 minus 1 divided by, and it's 1 plus the equivalent interest rate P to the exponent n. Remember, because it's a general annuity, divided by the equivalent rate of interest P. So what items here do we know? We know our payments are $1,000. We know our nominal rate of interest J is 10%, which is 10 divided by 100, which gives us 0.10. Our number of interest compounding periods, M. Interest is compounded quarterly, so M is 4. So our periodic rate of interest, I, is J divided by M, or 0.10 divided by 4, which gives us 0.025. Now we need to calculate our ratio, C. Okay, so C is the number of interest payment periods divided by the number of payment periods. Interest is compounded quarterly, and payments are yearly, okay, which means only 1 payment a year, so our ratio is 4. What this means, we can now calculate our equivalent rate of interest P, which is 1 plus I to the exponent C minus 1. I is the periodic interest rate. So P is equal to 1 plus 0.025 to the exponent 4 minus 1. And if you calculate that out, you get 0.1038. Our last term we need is the number of payment periods, total number, N. And this is 5 years, multiplied by 1 payment a year. So it's simply just 5. So if we calculate this out, we substitute everything in, our present value is equal to our payment, 1,000, times 1 minus 1 divided by 1 plus the equivalent interest rate, 0.1038, to the exponent 5, divided by 0.1038, that equivalent interest rate. Okay? And if you calculate everything in the brackets, you should get 1,000 multiplied by 3.754 to give you a present value of 3,754. So that is your present value at year 3 for the very start of the annuity when payments have to be made. Now you have to discount that back to year 0, and that's done using compound interest. So I'll do that in another color here on the right. So that means if $3,754 is the value at year 3, and you're trying to get to all the way back to year 0, that's the future value in that formula. So you're trying to find the present value again. So the present value is equal to the future value divided by 1 plus the periodic interest rate to the exponent n. Okay? Because this is simply an interest calculation. So in this piece, it has nothing to do with whether or not you have payments, because you're just doing compound interest, right? So remember, it doesn't matter. You're not going to have this value p here, right? Because it's just compound interest. So the variables we know here, we know I, okay, our periodic rate of interest, it's 0.025. Our future value is $3,754. And our value for n, which we don't know, it was deferred for 3 years. Okay, and interest is compounded quarterly. So we have 12 interest periods. 3 times 4 is equal to 12. So we can simply substitute these values in. The present value is equal to the future value, 3,754, divided by 1 plus our periodic interest rate, 0.025, to the exponent 12. And this gives us a value of $2,791.31. Okay, so that was simply working backwards when you're trying to find present value. Okay, so doing the annuity calculation first, and then doing your compound interest calculation. And remember, the compound interest only cares about the interest, okay? Because it's not an annuity at that point, it's just an interest calculation. All right, so that's why the periodic rate of interest was used there. Okay. So our last topic is on perpetuities. Okay, so this is the second type of kind of special investment I want to talk about in this lecture. So perpetuities are annuities that the payments begin at a certain time and they continue forever. There's never a stop date to them. So that sounds crazy, and that's because it largely is. They're very rare in today's investing world. Sometimes stuff like that was given out previously during wars to raise money, but there's not a whole lot of relevant examples today for perpetuities. So there's ways to calculate them. I'm going to show you kind of how the formulas are developed, but I'm not going to test you on a specific question with a perpetuity. Okay, so one thing that you need to know as a starting point is, since they continue forever, you can never calculate the future value, right? How can you calculate a value in the future when you don't know how many compounding periods there are? Because it just continues forever and ever and ever. It doesn't have a fixed end date like every other question we've had. But you can calculate the present value. Okay, so I'm going to just kind of walk you through how that formula works. Okay, so let's take the example of an ordinary simple annuity. So the present value, okay, in this instance is equal to the payment times 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n divided by I. Okay, that I, the periodic interest rate. Okay, so if you can know the payment and you can know your interest rate, But how do you calculate the number of compounding periods? Remember, n is equal to the number of years times the number of compounding periods per year, okay, or number of payment periods per year. Well, number of years goes on forever. That actually approaches what's called infinity, which is a number that just is so large that we just call it infinity. So n is actually what's called infinity. Okay, so when you substitute that in, if you try and take a number, so the present value is equal to the payment times 1 minus 1 divided by 1 plus your periodic interest rate to the number infinity divided by your periodic interest rate. Well, that number is so large, right? Because it's a number raised to the exponent. That 1 divided by a huge number is just going to be almost nothing. Okay, so it's just going to be 0. So that whole value just cancels. And what happens is you have your payment multiplied by, oh, that's a really bad bracket, multiplied by 1 minus, that just becomes 0 because it's so small, you just assume it's 0, divided by your periodic interest rate. So the payment times 1 minus 0 is just 1, so that cancels. So your formula just becomes your payment divided by your periodic interest rate. Okay, so I'm showing you how these are derived and kind of what they mean. There's a financial theory called the dividend discount model where some of this might be used. It's more of a more advanced kind of financial theory. So I just wanted to show you what perpetuities are. So that's kind of how you can calculate them. And again, you can't calculate anything other than present value. So the same thing actually applies if you were to try and do it for other types of annuities, whether it's a general annuity or a simple annuity. So again, I wanted to just show you them so you understood them, whether or not you followed this infinity piece that I added. But I will not be testing you on perpetuities. Okay? If you do want to look at some questions on them, it's section 13.5 in your textbook. Okay? You can kind of see they show it a slightly different way to derive this formula. But if you do want to look a little more into doing some of those questions, you can. But like I said, you will not be tested on them. So that was all I had for this lesson. You'll see I only have exercises from 13.3 and 13.4. Those are both on deferred annuities, so annuities and annuities due. Okay, so I did not include 13.5, which is perpetuities. So that's it. Thanks, everybody.